Good morning, ladies and gents. Okay, so we are taking up the first part of your review on page 477 for probability. So first to ask, probability of a certain event. Well, that would be, if it's certain, it's guaranteed to happen, it's 100%. And the next one asks probability of an impossible event. Well, that's going to be 0%. Next, we're asked to estimate or calculate each of the probabilities. So Chris yanked an orange out of a basket that contained 2 oranges, 6 apples, and 8 peaches. So it's for probability of an orange, favorable outcomes over total possible. There were 2 oranges out of a total of 16 pieces of fruit, 12.5%. For 2, it said March immediately follows April. Well, it doesn't, so 0%. 3, roll a 1 to a 4 on a dice. So again, favorable over total possible. Our favorable outcomes are 1 to 4, so there's 4 of them, so that would be 66%, 4 divided by 6. Part 4, cold in the Arctic in January. It's very, very likely that it's cold in the Arctic in January, so I put that at 99%. And the last one said, you will have homework tonight. Well, there's no wrong answer for this. It's just whatever you think based on you, but I put it as 5%. Okay. Number 2 said, weather report says there's 60% chance of snow, probability that it will not snow tomorrow. Well, again, probability is based out of 100%. So if it's 60% chance of snow, if we remove that from the total, we're left with 40% chance of no snow. 3 said 5 out of 8 voters are going to vote Liberal, and they want to know how many voters out of 180,000 are not going to vote Liberal. So 5/8 vote Liberal. Out of 180,000, how many will not vote Liberal? Well, if 5/8 are voting Liberal, that means 3/8 are not voting Liberal. And then this is like our percent unit with a little bit of our fractions unit. So they want us to figure out what 3/8 of 180,000 is. So 3/8 as a decimal is decimal 375 times 180,000, 67,500. For number 4, prime numbers game. If you rolled a prime number, you get 10 points. If you roll a composite number, you get 1 point. And they asked us to figure out all the possible outcomes by making a little table. So it's just all the numbers on the dice multiplied together and what you can get. And then I've highlighted the prime numbers, 2, 3, and 5, 2, 3, and 5. And then for B, it asks, if they played 60 times, so they rolled 60 times, how many points would each person get? So probability of getting a prime, favorable outcomes over total possible. Well, there's 36 possible outcomes here. And then how many prime numbers? 1, 2, 3, 4, 5, 6 for each of them. So 6 divided by 36, 16.6% chance. So 16.6% chance in 60 rolls tells us that they'd probably get 10 prime numbers coming up. And then the beginning of the question told us that you get 10 points. So they'd be getting 10 points 10 times, 100 points. So if this person's getting 10 of the rolls, then this person's getting 50 of them, but they only get 1 point apiece. So they'd be getting 50 points. So is that fair? Well, no, not really. And that's what part C tells us, or is asking us rather. There's too many points awarded to the person getting the prime numbers, even though they come up very seldomly. D said, could you list a tree diagram to list the outcomes? Sure. It would just be a lot bigger than this. Tree diagrams are excellent for certain things, like we'll see in the next question. But for this is a much more compact way of doing it, although a tree diagram would give you the same thing. So it's just, what could you roll on the dice on here? What could you roll on the dice on there? And then the second or the third part that I forgot to put in would be the outcomes. So for example, because we're multiplying, we'd have to show 1 times 1 is 1, 1 times 2 is 2. Down here, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and show all of those outcomes over here. Okay, so number 5, Mario's Deli offers sandwiches on rye or whole wheat bread with a choice of turkey, ham, or pastrami for meat, and mozzarella, Swiss, and cheddar for the cheese. And it asked us to make a tree diagram to show all the different possible sandwiches. So I started with cheese, mozzarella, Swiss, and cheddar. And then assuming I chose mozzarella, then I have a choice of meat, turkey, ham, or pastrami. Assuming I went mozzarella turkey, I then have a choice of bread, rye or whole wheat. And then I did that for all of them. And then showing the possible outcomes. And again, for possible outcomes, you just follow a trail to each endpoint. So mozzarella turkey rye, mozzarella turkey whole wheat, mozzarella ham rye, mozzarella ham whole wheat, so on and so forth all the way down. Okay. B asked us to calculate the probability that Maya will get Swiss cheese on rye bread. So Swiss cheese right here, rye bread. Well, there's a Swiss with a rye, there's a Swiss with a rye, there's a Swiss with a rye. So there's 3 options. And then again, favorable over total possible. For total possible, you could count all your possible outcomes, or I mentioned in a much earlier video, a way of doing it is just multiply how many choices there are. So there's 3 choices for cheese, 3 choices for meat, 2 choices for bread. 3 times 3 is 9, times 2 is 18. That's a good thing to do just to see if you have all the proper number of possible outcomes written down. So it's a way of double checking that, your tree diagram's working out. So then 3 divided by 18, 16.7% chance. So probability that she could get a cheddar cheese but no turkey. Well, cheddar cheese is here. The turkey is there, so we can't use these 2 choices. So how many choices are left with cheddar and no turkey? Well, 1, 2, 3, 4 of them. Out of 18, 22.2%. Okay, hopefully that helps. And you know how to get in touch with me if you need anything. Bye for now.